Alright, so we're going to talk about something called molarity. So I want you guys to write this part down, the part that I highlighted, because that is going to be our formula for today. Okay, molarity. We represent molarity with the letter capital M. And molarity is the moles of solute. And so this is pretty much how much stuff is dissolved in there. So how much stuff divided by the liters of solution. And this is your volume. So pretty much how much stuff is dissolved in certain amount of water.
Wait, should we write this down?
Yes.
Yes. Oh my God. I know some ways to measure it too. It's like pressure or like PPR or something. Like, for example, like if it's already diluted and let's say it's pulling out of like a downstream.
Okay, so for number one, we're going to take a look at this problem. We're going to find the molarity of a 1.25 liter solution that contains 0.8 moles of AgCl2. So before we start, I want you guys on your paper to write number one, and we're just going to write the formula down. Molarity is moles divided by liters. Okay. So we're going to be using this equation for all of our problems today. Molarity is moles divided by liters. Yes.
Does it matter if it's capital or not?
Yes, it matters. Yeah. All right, and then all we got to do is look at the problem, pull out the numbers, and just plug them into the correct positions. Okay. So let's start from the beginning. So what is the molarity? So molarity is what you are looking for. So out of these three, which one is molarity? Yeah, capital M. So we are looking for capital M right here, okay? And then it says of a 1.25 liter solution. So where on the fraction should we plug in 1.25?
On the bottom.
Liters on the bottom, exactly. Great. Okay, and then it says it contains 0.8 moles of AgCl2. So,
0.64.
okay, great. So we're going to put 0.8 moles on the top. Okay, so that's how you plug in the numbers into the molarity equation. You just need to figure out where everything goes. All right, so on your calculator, if you have a fraction, you always do top number divided by bottom number. Hopefully you guys remember that from stoichiometry. But 0.8 divided by 1.25, that means that our molarity is 0.64. And then we have to label our number capital M for molarity. So that is going to be the molarity of this solution. Yes?
So, can you put AgCl?
Yeah, you can put AgCl2 as well.
Okay.
Yeah, so the full, I guess the most accurate answer would be molarity AgCl2.
Okay.
Yeah.
Do we have to say that?
Nope. All right, so what this is telling us is if you have a solution, so you got like a container, some liquid, let's say the solution is 1.25 liters, and you have 0.8 moles of AgCl2 in there. That means the concentration, or how strong this solution is, the number for that is 0.64 molarity. Okay, so this is telling us the concentration. All right, any questions? Yeah. Just a number. Any other questions? This is the easiest problem. Don't worry, guys. It'll get a little harder than this. All right. Let's move on to number two. So number two is very similar, but we're going to have to do some extra steps. Okay, so for number two, I want you guys to write number two, and you're going to write down the equation again. So molarity equals moles over liters.
Do we have to write the equation again?
Yes. It'll be helpful.
But it's like...
It'll be helpful. Okay. You can do whatever you like. It's your notes. Okay. All right. So molarity of a 9,700 milliliter solution contains 1.2 moles of ZnBr2. Okay. So we're gonna plug in our numbers. But if you guys take a look at this problem, what's the issue that you guys see with this problem? It's in milliliters, but we need our number in liters, right? So we have to convert this into liters. So the way that we do that, very simple, is you divide it by 1,000. Okay. Another way you can do it, if you guys want to not do any math, just find the decimal point for milliliters, move it 3 times to the left. That's dividing by 1,000. Just the way the math works. It's 9.7 liters. If you don't believe me, you guys can plug into your calculator, do 9,700 divided by 1,000. Either way, you're going to get 9.7. Okay, so now we can start plugging in our numbers, right? Okay, so molarity is what we're looking for. What number should go on top of our fraction?
1.2.
Yeah, 1.2 moles. And then what number goes on the bottom? Perfect. 9.7. Easy.
Divide those two?
Yep. So we're going to plug it into our calculator. Okay, and you're going to get, I'm just going to round it off, two numbers after the decimal, 0.12. If you wrote 0.123, that's fine. Again, your numbers can be a little different than mine. As long as they're close, you're fine. Yeah, 1.2 divided by 9.7. You'll get 0.12.
Do we always round to the nearest hundred?
Yeah, I would always recommend two non-zero numbers after the decimal. Yeah. So if it was like 0.012, then make sure you write the 12 as well.
Oh,
Yeah.
but usually just round to the nearest.
Yeah, hundredth is safe usually. All right, easy peasy. Yeah,
It was like 0.125. I round up to 1.
you can do 1.3. Yeah, again, as long as it's close. All right, let's add one more dimension to this. So when we start making our solutions for our labs, you're not gonna be given moles, right? When you weigh out stuff in a lab, what unit of measurement do you usually get? Grams. And so you're not just gonna be given moles. You got to figure out how to turn grams into moles and vice versa. So make sure you guys have your periodic table because we will be using it. And then for this problem, we're gonna be using our periodic tables and for molar mass. Okay. So same thing. So write number 3, and let's write down the formula. Molarity equals moles over liters. And then we're going to just try to plug in our numbers into this equation. All right, we're looking for molarity. So we're looking for capital M again, same thing as before. Let's see if we can plug in any numbers into this formula. Okay, so it's asking what's the molarity of a 100 milliliter solution. So this is 100 milliliters, so what do we need to do with this number?
Divide by 1,000.
Exactly. Divide by 1,000 because that gives us liters. Okay? Or you can move the decimal 3 times to the left. That'll give you 0.1 liters. Okay, and that's what we're going to plug in on the bottom right here. 0.1 liters.
And is it 3 moles?
All right. Everybody good so far?
Yeah.
Okay, let's move on to the new part. Okay, instead of giving us moles, it gives us 3 grams of salt, which is NaCl. And so if you guys look, we can't plug in 3 right here because it's 3 grams, right? This needs to be moles. So this is not going to work. Instead, what we're going to have to do is we're going to have to take the 3 grams of NaCl, and we are going to turn it into moles. That way we can plug it into the top of the fraction. Okay? Now, I know it's been a really long time since we did this, so I'm going to go through this with you guys. If you guys remember how to do molar mass, go ahead and do it. You can ignore me and solve it. But since it's been, I think, like 2 months since we touched molar mass conversions, we'll go through it together. So what we're going to do is, in order to turn grams into moles, we need to use something called the molar mass. Okay, so to find molar mass, we need to use the periodic table. So let's look at the periodic table. If you guys have yours, you guys can pull it out. If you guys don't have your periodic table, I got some next to the projector, so you guys can pick it up. Yeah, it's yours. Okay, so make sure you have your periodic table, and I want you guys to take a look at Na and Cl. Okay, we're going to find the molar mass of NaCl. And in order to do that, we need to add Na and Cl. Okay, so let's look at the numbers on the bottom. Na is 22.99. Na is on the very left, third row. And then to find NaCl, we need to add that with Cl, which is on the very right side, which is 35.45. So Na is 22.99. Look on the left side of the periodic table right here. So Na and Cl is 35.45. So NaCl is going to be those two numbers combined.
What is Na?
22.99. So if we add them together, we're going to get 58.44. So on our paper, we're going to write down that the molar mass is 58.44 grams equals 1 mole. Okay, so NaCl, this one is 22.99. Cl is 35.45, and we add them together to get 58.44. God bless.
Grams means nothing, basically.
The what?
Like the 3G. And
No, it matters. We're not done with it yet. Yeah, we got to use it to turn it into moles. Yeah.
To get the NaCl itself, basically.
All right, moving on to the calculation. Okay, so we are going to write 3 grams of NaCl, and in order to turn it into moles, we have to set up a fraction. So let's set up a fraction. Okay, I know you guys are probably getting PTSD from this, right? Okay.
Can we just times it by 3?
No. So what we're gonna do is we're gonna set up our fraction, and if you guys remember, if you want to get rid of something with the fraction, where do you put the same thing on the fraction? The bottom. So since you're trying to get rid of grams, we put grams on the bottom. So whatever you're trying to get rid of,
Oh, yeah.
you put it on the bottom. So you have grams. You want to turn it into moles, so you put grams on the bottom. And what you are looking for, you put on the top. So grams on the bottom, because that's what you're trying to get rid of. And then moles on the top, because that's what you want to find, so that you can plug it into your equation right here. No, not yet.
Wait a minute. Okay, so you already done moles.
Not yet. We found molar mass. We have to use this to find moles. We haven't found moles
This
yet.
is a brand new thing we're learning.
No, we learned this back in like October. Okay. So again, we got 3 grams. We have to turn it into moles to plug it in here, right? To do that, we need the molar mass. So we went to the periodic table, found 58.44. We're going to set up a fraction. 3 grams, we're trying to get rid of grams, so we put it on the bottom. That way they cancel each other out. And then we're going to plug in this number into this fraction. Okay, so you got moles on the top. What's the number next to moles in molar mass? 1. So we put 1 on the top. And then the 58.44 goes on the bottom because that's where grams is. That's correct. So we do top divided by bottom. So let's start from the left and go to the right. So we have 3 as our starting number. And then we're going to divide by 58.44. Okay? Because 3 grams is what we start with, right? We're trying to turn 3 grams into moles. So 3 divided by 58.44. Yeah.
Since it's always going to be 1 mole too, you don't have to do that, can you just do the...
Yes, you should, because everyone says they got it, and they mess up when they don't do it like this. Okay? Okay, so 0.05, and then it's going to be moles. So now that we have moles, what can we do with it? We can plug it into the equation, and then we're all done. So 0.05.
Wait, to get to 0.05, can we put that in the calculator?
Yeah, you should do this on a calculator. 3 divided by 58.4.
Oh, okay.
Yeah, and I know this is a lot of work, guys. It's a lot of writing. I know some of you guys don't like writing the fraction, but the fraction makes sure that you multiply or divide properly. Okay, I know it's a little bit irritating to do, but if you want the correct answer, I do recommend doing this. Also, I can help you guys out because I can see where you went wrong. Yeah.
Okay, so if we just have like one thing like NCCL, right? So couldn't we just like divide it by 3 and then get our answer?
All right, guys, let's finish the problem. So we have 0.05 divided by 0.1. So 0.05 divided by 0.1. Oops, sorry. And then that'll give us our answer of 0.5. So our answer is 0.5 molarity. Okay, and this is pretty much what you'll be doing for your labs going forward, because what you're going to do is you're going to have to make certain solutions. So this solution is going to be 100 milliliters. So you got a container with 100 milliliters. And then in order to make something that's 0.5 molarity, you have to add 3 grams of NaCl into it. So it's a lot. It's kind of like writing a recipe for the solution that you want to make. And that's pretty much what we'll be doing for this unit. And I think this goes until like March. So we'll be doing this for a while. Okay. All right. Any questions on number 3?
Wait, so we're going to be doing this all of February?
Pretty much. That's what the unit is. All right. So we're not done because these were the easy calculations. Now we're going to the ones that you'll actually be doing for your labs and for your assignments today. Okay. This is just kind of the foundation stuff. All right. So when you guys are working in your labs, I will not be telling you, or I'm not going to be asking you guys for a molarity. Instead, I'm going to tell you to make a solution with a certain molarity. So on your paper, I want you guys to write down number 4. or just write number 4. And then on there, I want you guys to make or draw this. We're going to draw a little container. It's going to be some water. Okay, and what I'm going to have you guys do in your labs, I'm going to tell you, hey, I want a solution that is 0.2 molarity. It needs to be 1,200 milliliters. And I'm going to ask you, how much CaCl2 do you need to put in here to make this solution? So that's pretty much what you'll be doing in your labs for this unit. I'm going to tell you guys the molarity, the concentration, and how much I want you to make. And you're going to have to figure out how much of the chemical you need to add in order to make that solution. Okay? Now, the steps are pretty much what we've already learned. It's just the order is going to be a little different. So I'm going to go through it step by step with you guys. Okay? All right. So the first thing that you want to do, if you guys take a look at this problem, is our number is in milliliters, right? So what do we need to do with that?
Divide by 1,000.
Exactly. Divide it by 1,000 to turn it into
1.2.
liters. Yeah, 1.2. So step 1, let's write that down. Step 1, we're going to take 1,200 milliliters. We're going to divide that by 1,000, and that's going to give you 1.2 liters. That is step 1.
So this is what's going to be on our assignment today?
And your quiz is this type of problem too.
Oh, we got a quiz too.
Yeah, back to normal.
Hey. I forgot about this.
I know. The project was nice, huh?
It was nice. It was fun.
All right, so that's step 1. Step 2 is we're going to have to use the molarity formula. So let's write down the molarity formula. Molarity equals moles divided by liters. Okay, so step 2 is molarity is moles divided by liters. All right, let's start plugging in our numbers. So if you guys take a look at our first number, 1.2, where should we put it in this equation?
Top.
Liters.
Or bottom.
Yeah, bottom, the liters part. So we're going to plug it in right here. So let me just draw an arrow, and then I'll draw a fraction. And on the bottom, we're going to put 1.2 liters. All right, and then if you guys take a look at the problem, what number is the second number that they give you?
0.2.
0.2 what, though?
Liters.
Not
Liters.
Not molarity. Yeah.
So, couldn't we just divide 0.2 or multiply 0.2 by 1.2 to get our answer?
Yes, you will. So if you can skip steps with your math, go ahead. But I'm just showing you guys how we get that. So we got 0.2 molarity, right? Capital M. So we plug it in here. We have 1,200 milliliters. So that's liters. That means the number that we don't have is moles, right? So in this step, we are going to be looking for moles.
So those would be the opposite.
Yeah, so if you guys take a look at this, this is just regular algebra, right? Let's pretend instead of moles, we're saying this is x. Okay? I know. The way that you solve it is you want to isolate x. So what we're going to do is we're going to multiply by 1.2 on both sides. So multiply both sides by 1.2. That way, this cancels out. And on the other side, we're going to get 1.2 times 0.2.
It's just the reciprocal.
It's not the reciprocal.
It's not.
Reciprocal is when you flip the
Just
fraction.
canceling it out, right? Like,
Yeah.
You basically do. It's like 1.2 over 1.
Okay, so the way that we solve for moles is going to be 1.2 times 0.2.
1.2.
Okay, and again, the reason we do that, yeah, so that is the reason we do it is so that we can cancel out the 1.2 that's connected to moles. We want to isolate moles on one side of the fraction. So we multiply by 1.2 on both sides to cancel it out.
Okay. So you just multiply that.
Okay, so for your moles, we're going to plug it into our calculator. We're going to do 1.2 times 0.2. That's good. We're not done, though. Almost there. All right, so that's step 2. Any questions on step 2? It's just algebra. You guys should have seen this in your algebra classes already. Yeah.
So 1.2 times 1.2 will be equal to 1.4, right?
Yes. Sorry, if it's confusing the way I wrote it, let me write it like this. Is this better? Okay, my bad. I apologize. Okay, so we got 0.24 moles, and let's label the moles now. What's the chemical that we're looking at in this problem?
CaCl.
Yeah, it tells you right here, CaCl2. So we're gonna write down its moles of CaCl2.
Oh.
So we're almost done. We got one step left. If you guys notice, for step 2, we just found moles of CaCl2, right? Now what we're going to do is we're going to turn this into grams of CaCl2. So step 3 is what we just did in the previous problem. We're going to turn moles of CaCl2 into grams of CaCl2.
How many of these are like on the?
I don't remember. Okay, so let's set up our fraction. And I'm going to give you guys about 2-3 minutes to do this. Go to your periodic table, find the molar mass. Let's see if you guys can set up the fraction properly and get the grams of CaCl2 that you need, okay? Okay, guys, so the molar mass of CaCl2, if you guys take a look at the periodic table, is you guys should have gotten, I believe, 110.98, right?
Yep.
110.98.
There's 2 CLs.
Yeah, there's 2 CLs. So, if you guys look at Ca, it's 40.08, right? Cl is 35.45, so you got to make sure you guys get 2 of the Cls. Okay, so 40.08 plus 35.45. Okay. All right, everybody good with the molar mass?
Don't you have to times it like? Or you do that?
Yeah, the 2, if you want to do 35.45 times 2, that's fine as well. You're at the same number.
3.24.
You add 2, you
Yeah.
add, you don't
Yeah.
do multiply.
You can multiply the CLs, but you got to add it. Just leave them there for a bit. Yeah.
Oh, so you could do 35 times 2 plus 40.
35.45 times 2 plus 40.08. All right, so we got to plug it into this fraction right here. All right, so let's see if you guys put the numbers in the correct positions. You're trying to get rid of moles, right? So where should moles go on this fraction?
On the side.
Bottom, yeah, denominator. And then grams goes on top. All right, let's plug in our numbers. Okay, so what number should go on the top?
110.98.
Yeah, 110.98. Hey, leave it closed. Leave it closed. Okay? Because the number, we want to get rid of moles. If you want to get rid of something, you put it on the bottom of the fraction. Yeah. Because you have moles. You start with moles. You're trying to find grams out of it. Yeah, so it's the reverse of what we were doing earlier. Okay. So moles goes on the bottom. And then what number should go next to moles? 1.
So if you go use the bathroom, you can
They're sweeping today, so.
You sweep every day.
So they're gonna sweep every day.
All right, so from here, you guys should see that 110 goes on the top because grams, 1 moles on the bottom. And then if you guys notice, our numbers are, the numbers on top. So if the number's on top, what should we do with it on the calculator? Multiply. So what we're going to do is we're going to do 0.24 times 110.98. And so our final answer here will be 26.64 grams of CaCl2. And that's our final answer.
Oh. We don't have to find out.
Okay? Because the question's asking how many grams do you need? And so basically, in order to make this solution right here, you need to add 26.64 grams of CaCl2. Okay, and that's how you solve that out.
It's not hard, it's just a lot of steps.
It's a lot of steps, but just make sure you have these 3 steps written down on your notes. And as you guys are doing your problems, just follow the 3 steps. It'll be very helpful. And don't worry, I'm recording this as usual, and I'll be putting it on Canvas. So if you missed anything or you need a refresher, it'll be there. First step is you wanted to turn milliliters into liters. Just make sure you guys did 500 divided by 1,000. You get 0.5 liters. Step 2, we're going to use the molarity formula and plug in the numbers that we have. If you guys take a look at the problem, we have 0.75 molarity, so we're going to put that on the left side of the equal sign. So 0.75 molarity equals, you're looking for moles, and then you're dividing it by 0.5 liters. Okay? All right, now to isolate the moles, we need to multiply both sides by 0.5. So to get moles, we're going to do 0.75 times 0.5. Everybody good with that so far?
Yep.
Just isolating? Okay, so your moles are going to end up becoming 0.375. Okay? And if you guys want to be specific, it's going to be moles of CuF2. Okay, so I'll pause right there because that's the end of step 2. Any questions on step 2?
375, right?
Yeah.
So basically, you gonna know that you're just multiplying the molarity with the leaders.
All right, so for step 3, what we have to do is we need to take the moles of CuF2 and turn it into grams. Now to do that, we need the molar mass, so you're going to look at the periodic table. I'm not going to pull up the periodic table here, but you guys can double check me if you want. Cu is 63.55. F is 19 each, and there's 2 of them, so plus 19 twice. Okay, so if you add them up, let me pull up my calculator real quick. So you're going to get 63.55 plus 19 twice. That'll be 101.55. So this will be 101.55 grams in 1 mole. Okay? All right, let's do our conversion now. So for the last step, for step 3, we're going to take the number that we got from step 2, 0.375 moles. So 0.375 moles, and we're going to set up a fraction. Okay, I want to get rid of moles, so where should I put it on the fraction? The bottom. Whatever you want to get rid of, you put on the bottom, and then you put grams on the top. And then we're going to plug in the molar mass. You're going to put 101.55 on the top because that's where G is, and then you're going to put 1 on the bottom because that's where moles is. And so all we have to do here is multiply, and that'll give us our final answer. So 0.375 times 101.55. And so our answer will be pretty much 38.08 grams of CuF2. All right, and that's it. That's going to be your calculation.
So where does the 1 mole underneath it go?
What do you mean? Like for our calculations?
Yeah.
You can divide it by 1 if you want, but it'll be the same number.
Right, it still says mole. Or in number 3, see how it says like 1 mole? And